So here's my XY grid. Here's a point. I'm just making it up. Maybe that's the point 2, 1. Here's a point over here. Maybe that's the point, I don't know, 8, 7? I don't know. And we want that distance. We want to know how far those 2 points are apart. So the advantage of the XY grid is that everything is right angles. Yeah, our axes are at right angles. Everything is vertical and horizontal. So this means that I can find myself a right triangle like that. So in this 2, 1, let me grab some colors. Hang on a second. If we have the 2 here tells me about how, tells me how far across I am. Yeah, that's the number 2 here on the x-axis. And this 8 on these coordinates tell me that I've gone across a distance of 8. That means that if I subtract the 8 and the 2, I know how long this, let's make it green, I know how long this green side is. That's going to be 8 minus 2, which is 6. And I can do the same story in the vertical. Let's use orange. So this point here, 2, 1, the y-coordinate is 1. That means you've come up to a height of 1. And over here, my y-coordinate is 7. That means that you came up to a height, to a height of 7. So this vertical side of my triangle, well, it's as high as 7, but it only goes down to 1, so that's a side length of 6. And I made a big deal about right angles and things, and at the time I should have put the right angle in. So here's my right triangle. So this is the distance that we want. And I'm just going to redraw my triangle so I don't have so much mess to look at. So here's my triangle. Not an artist. Forgive me, I'm not an artist. Okay, so we said that the orange side was 6. The vertical side and my horizontal side. Oh, they both come out 6. That's not on purpose. That's completely accidental. This is what happens when you let me make numbers up off the top of my head. Okay, our green side is 6. You won't always get the same number. And this is the side that we want, and this is Pythagoras. This is why people say that the distance, if you want to know the distance between 2 points, you're basically using Pythagoras. So I know that d squared is 6 squared plus 6 squared. D squared equals, well, that's 2 times 36, which is 72. Oh gosh, sorry, that's off camera. I'm new to this. Sorry, you're my guinea pig, aren't you lucky? So the distance, so when you square root things like this, technically you do have to put that plus or minus, 27, what am I like? You do have to put that plus or minus in, but because it's a distance, we take the positive version because it's an actual distance. You could say you have a negative distance, but generally we don't do that in geometry. We'll give it a positive distance. Okay, so this is all based on Pythagoras. So if I try to scoot things off my desk so I can show this up. Okay, so in general, what we what we did here is to get this orange side, we subtracted the y-coordinates. To get this green side, we subtracted the x-coordinates. So in general, I can say this. Okay, so here's a fresh set of axes. Here's my x. Here's my y. If I have a point here, and I'm going to give him generic coordinates, and it looks kind of fancy, but it's not that bad. It has an x-coordinate and a y-coordinate, but I'm going to say x sub 1, y sub 1. These little ones mean that's the first point I'm interested in. Then you have a point over here, and he's got coordinates x, y, but he's my second point, so I'm going to say x sub 2, y sub 2. These are subscripts. And it's just to say that those x's and y's go together these x's and y's go together. So this is the distance we're interested in. I do that in purple. That's my distance I want. And we find a right triangle again. If you go across like so, here's your right triangle. And that was our vertical distance. And that vertical distance was the difference in the y values. So this y distance is y2 minus y1. And this x distance is the difference in my x coordinates. Sorry, I know that's annoying to skip the pencil, isn't it? Here are my x coordinates. And that length was my x numbers subtracted. So x2 subtract x1. And at this point, you might start worrying about the order you do the subtraction in, because you know that 10 minus 7 is 3, but if you say 7 minus 10, that's negative 3, and you might start to worry. But in Pythagoras, when we take the difference, we square it. So it doesn't really matter whether we said 7 subtract 1 or 1 subtract 7. If we had said 1 subtract 7, then this would be a negative 6, but we're squaring it anyway, so it's going to come out as a positive number regardless, so we don't have to worry about the order we subtract, and that's quite slick. So we can say, well, from Pythagoras, our hypotenuse, that's d squared, equals the orange side squared plus the green side squared. Or the green side squared plus the orange side squared. It doesn't really matter which way you do it. I suppose we'll start with the x's. That's conventional. So it's the difference in the x's plus the difference in the y's, and that's your distance squared. Sorry, you poor guinea pig. You're really having a job to read what I'm doing here. That doesn't quite fit on the page. Bear with me. This is balanced on a stack of books. Okay, there we are. So the difference in your x's squared plus the difference in your y's squared, that's your distance squared. So if you want to solve for d, you can write this as a big fat ugly square root, if you must. You'll see it printed in books like this. And this is called your distance formula. And this will work wherever you stick the dots. I was playing in this first quadrant, but you could put the dots anywhere else, and you can still draw a right triangle, and you'll still have a vertical distance, that's subtracting your y's, and a horizontal distance, and that's subtracting your x's, and you'll still come to this formula. So that's the theory behind it.